This next unit we are starting on is all about functions. Now there's a lot we can talk about in terms of functions, and we're going to cover a lot in this chapter on different things about functions and what you can do with them. Today we're going to talk about how do you determine whether or not something is a function. We're going to talk about how you can evaluate functions. We're going to talk about the difference quotient and how you can find the difference quotient given a function. And we'll talk about how you can determine from an equation whether or not it is a function or not. So let's start with what a function is. So a function is a relation in which each input corresponds to exactly one output. So in other words, no x values can repeat. So it's a relation in which each input corresponds to exactly one output. No x values can repeat. Now, in order to determine from your function what is your input and what is your output, you want to think about what is the information that depends on other information. So take a look at this for example. The amount of income tax you pay depends on your income. So depending on your income, the amount of income tax that you are going to have to pay is going to be different. So that means that if you input your income, the output will be your income tax. All right, so that means x is the part that can change and y is the part that depends on x. Let's try the next one. The Weather Bureau records the temperature over a 24-hour period in the form of a graph. The graph shows the temperature that corresponds to each given time. So you want to think about, does the temperature depend on the time it is, or does the time depend on the temperature? Well, we know at a certain time it could be a different temperature. It might not necessarily be what you expect, but it would be still that same time. So the time is the independent variable, and the temperature is the dependent variable. So because the temperature depends on time, you would say that the input would be the time, and the output would be the temperature. All right, so when we talk about a function, we want to think of a function as three things. First, a set of inputs called the domain, so these are your x values. Some rule, which really is just another way to say an equation, by which each input determines only one output. And thirdly, a set of outputs called the range. All right, let's look at example 2. Determine whether the relation is a function. Okay, so taking a look at this, we see the inputs in the first row and the outputs in the second row. Is this a function or not? Remember, for a function, for every x value, there's only one y value. In this case, we have 1, 5 and 1, 6. For the one input 1, there are two different outputs, 5 and 6. So because we see that, we know this is not a function. In fact, we also have 3, 8 and 3, 9, which is another place which can tell us that it is not a function because 3, the input, has two different y's, the outputs, 8 and 9. Looking at this next one, we have, again, the inputs in the first row and the outputs in the second row. You see that we have this repeated value, right? 1, 5, 3, 5, 9, 5. Now that's okay to have a repeated y value because for the number 1, for the input 1, we only have 5 as an output. Even though it is the same as the output for 3, that's okay. So it is okay to have repeated y value. So this is a function. Now, evaluating a function. So say you're given some rule of a function, for example here, f of x equals the square root of x squared plus 1, and you have to determine what f of 3 is equal to. So this notation really just tells you when x equals 3, what is the value of y. So what we're going to do is we are going to plug 3 in for x, so this is equal to the square root of 3 squared plus 1, which is equal to 9 plus 1, which is 10, so square root of 10, and that's it. Let's do the same with f of negative 5. So we plug negative 5 in. Make sure you put negative 5 in parentheses before you square it. Once you square it, becomes positive 25, and then you add 1 to that, and we get square root of 26. Okay, the next thing we're going to talk about is the difference quotient. Now, the difference quotient you may have seen before in algebra. We are reviewing it again now, particularly because it is important when it comes to calculus. And since this is pre-calculus, knowing the difference quotient will help you for calculus, and that's our goal here. So here's the difference quotient, f of x plus h minus f of x all over h. Now I won't go into too much detail about what this is, but really what it is it's a way for us to find the slope of any curve at a very specific point. So normally with a line, it's easy to find what the slope is, but with a curved graph, the slope is going to be different depending on where you are on the graph. And so the difference quotient is used to help us find what the slope is at different points. We're mostly going to be talking about the mechanics of how to actually go about working with this algebraically. So say you have f of x equals x squared minus x plus 2, and you want to find the difference quotient for this function. What you're going to do is you're going to start off by plugging in x plus h, that I've highlighted in purple there, into everywhere you see a blue x, that x squared minus x plus 2. So anywhere I see that x, I'm going to replace it with x plus h. And then for the second bracket, that's going to be just f of x. So I'm just writing out x squared minus x plus 2, putting it in brackets. And we're going to put that all over h. Most of this is just tedious work once you have this part set up correctly. So we multiply x plus h squared. Remember, this is x plus h times x plus h. So this is equal to x squared plus 2hx plus h squared. Distribute the minus, so we have minus x minus h plus 2. Distribute this minus, so this is minus x squared plus x plus 2, all over h. And now you want to see what's going to cancel out. So we have an x squared and a minus x squared. We have x and a minus x. We have a 2 and a minus 2. So that leaves us with 2hx plus h squared minus h all over h. And what we can do here is you can, in the numerator, factor out an h, leaving you with 2x plus h minus 1 in parentheses. Put that over h, and now the h's cancel. And that leaves you with 2x plus h minus 1. Now we won't go into too much about how we actually use this difference quotient, but just so you know, the way you would find the slope at a certain point is you would say when x equals this, then this is my slope, and you would set h equal to 0. So for example, if you wanted to know what the slope at x equals 1 is equal to, you would plug in x equals 1 and h equals 0 into this formula here. Let's do another example. So say this time we have f of x equals 3x plus 7. We're going to replace that x in the 3x plus 7 with x plus h. So this is going to be 3 parentheses x plus h plus 7. And then minus 3x plus 7 in brackets or parentheses. Put that all over h. And let's distribute. So this is equal to 3x plus 3h plus 7 minus 3x minus 7 all over h. Let's see what cancels out. We end up with the 3x and the minus 3x canceling, the 7 and the minus 7 canceling. So you're left with 3h over h. And actually the h's cancel here, which leaves you with 3. So what this means is that the difference quotient tells you that the slope of this particular function is going to be 3, no matter where you are. Now if you look at the function itself, 3x plus 7, you actually know that already because this is just simply a line. And for a line, the slope is going to be the same no matter where you are. So it's not dependent on the value of x. The last thing we're going to go over is how you can determine whether an equation defines a function or not. So say you have this, 4x minus 2y cubed plus 5 equals 0. So in order to determine whether or not this defines a function, you want to solve for y, get y by itself. So I'm going to move the minus 2y cubed over to the right, so I have 4x plus 5 equals 2y cubed. I'm going to divide both sides by 2, and then take the cube root of both sides. That leaves me with y equals the cube root of 4x plus 5 over 2. Now you have to ask yourself, if I were to plug in a value for x, do I get just one value for y? In this case, yes. So odd roots are going to be functions. Now what about this one? Y squared minus x plus 1 equals 0. You want to do the same thing. You want to solve for y. So I'm going to move the x and the 1 over to the other side. So that leaves us with y squared equals x minus 1. I want to get y completely by itself, so I have to take the square root of both sides. So you end up with y equals plus or minus the square root of x minus 1. Now when you plug in a value for x, now think to yourself, do I only get one unique value for y? So for example, if you plug x equals 2 in there, you end up with 2 minus 1, which is 1, and you end up with plus or minus the square root of 1, so plus or minus 1. So you end up with two different y values for that one x value. So even roots are not going to be functions because you'll end up having to take either a square root or a fourth root, which is going to end up being plus or minus. Now that isn't to say that only odd roots are going to be functions. Sometimes you'll have y equals and there's not a root. It's just y equals 2x plus 2. That's going to be a function. But in terms of roots, if you see any roots, if there are odd roots, they are going to be functions. And if they are even roots, they are not going to be functions.